Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. How one man's persistence unlocked the secrets of the universe, the story of gravitational waves and the Nobel Prize. If I told you that a Nobel laureate grew up in a war-torn Europe, would you believe it? Imagine this, a young boy, torn from his home by the ravages of war, eventually rising to become one of the most significant figures in modern physics. It sounds like a gripping story, doesn't it? But this isn't just a fictional tale, this is the true story of Rainer Weiss, a man who changed the course of science, and in doing so, reshaped our understanding of the universe itself. Born in 1932 in Berlin, Germany, Rainer Weiss's early years unfolded in the shadows of World War II. It was a turbulent time, with the horrors of the Nazi regime casting a long and dark shadow across Europe. In 1939, as the war's brutality grew, Rainer and his family, like millions of others, were forced to flee their homeland. They left behind their country, their people, and everything they knew, finding refuge in the United States. At the age of 7, Rainer Weiss, a young boy, was now a refugee. He was thrust into an unfamiliar world, facing a future that seemed full of uncertainty. Can you imagine being in his shoes? Forced to leave everything behind? What did his future hold? The truth is, Rainer's future seemed unpredictable. Yet, that young refugee, who fled the horrors of war, would eventually become one of the most important scientists of the 20th century, forever remembered for his contributions to physics, particularly the discovery of gravitational waves. Rainer's story begins in Berlin, in a family with a unique scientific background. His father was a mechanical engineer, and his mother was a chemist. Growing up in such an intellectually stimulating environment, Rainer was exposed to the world of science from an early age. His parents' passion for their respective fields sparked his curiosity. Even though the world around him was descending into chaos, Rainer's home remained a place of learning and discovery. Little did he know that these early experiences would lay the foundation for his future career, one that would change the way we understand the universe. But as the war escalated, everything changed. In 1939, the Nazi forces expanded their grip on Europe, and the Weiss family, like many others, made the difficult decision to leave Germany. For Rainer, it meant leaving behind not just his country, but also his childhood. He and his family crossed the Atlantic Ocean to New York City, where they sought refuge from the horrors unfolding in Europe. The journey to New York marked a new chapter in Rainer's life. A 7-year-old boy, filled with uncertainty and fear, found himself in a strange new land. He had to adjust to a new culture, a new language, and a new way of life. The future was unclear, and the world seemed vast and overwhelming. But despite the many challenges he faced as an immigrant, Rainer persevered. In the United States, he found a new sense of purpose in his education. The same curiosity that his parents had fostered in him as a child became the driving force behind his intellectual journey. New York City became Rainer's new home, and it was here that he began to reconnect with his studies. It was also here that he discovered his true passion, physics. The complexities of the universe, the way everything fit together, captivated him. He had grown up in a world torn apart by war, but now, physics gave him a way to make sense of the chaos. It was more than just a subject, it became a calling. And though his path was unclear, one thing was certain: Rainer was on a trajectory that would take him far. Rainer's intellectual curiosity led him to one of the world's most prestigious institutions, the Massachusetts Institute of Technology, MIT. When Rainer arrived at MIT, he was stepping into a world that would challenge him in ways he had never imagined. MIT wasn't just another university, it was a genius factory. The brightest minds from across the globe converged at MIT to push the boundaries of human knowledge. For Rainer, the competition was fierce, and the pressure was immense. Every student at MIT seemed to have the potential to win a Nobel Prize. The stakes were high, but Rainer was undeterred. He threw himself into his studies, dedicating himself to understanding the mysteries of the universe. While MIT's labs were filled with cutting-edge technology, Rainer was more interested in solving problems. He was fascinated by the practical application of scientific principles, and he approached every challenge with a sense of urgency and purpose. He didn't just want to understand the world, he wanted to change it. It was during his time at MIT that Rainer became captivated by a particular topic: gravitational waves. These weren't just any waves, they were ripples in spacetime itself, caused by the most powerful and cataclysmic events in the universe, like the collision of black holes or the explosion of stars. Gravitational waves were predicted by Albert Einstein in his theory of general relativity, but detecting them seemed like an impossible task. The waves were so tiny, so faint, that the idea of measuring them seemed ludicrous. But for Rainer, this was the challenge he had been waiting for. Gravitational waves represented the ultimate puzzle, and he was determined to crack the code. The idea of studying these waves was both thrilling and daunting. If he could detect them, he would not only be proving Einstein's theory correct, but he would also be unlocking the secrets of the universe. To study gravitational waves was to delve into the very fabric of spacetime, to explore the hidden layers of reality itself. It was, in Rainer's words, like uncovering the code of the universe. As Rainer continued his studies, he realized that the technology required to detect gravitational waves didn't yet exist. The instruments needed to measure such tiny distortions in spacetime were nowhere to be found. But that didn't stop him. Instead, he began to think about how to build them. He envisioned an observatory, a place where scientists could measure the faintest tremors in spacetime, and in doing so, peer deeper into the cosmos than ever before. This vision would eventually give birth to the Laser Interferometer Gravitational Wave Observatory, or LIGO. LIGO would become the cornerstone of Rainer's career. But getting there wasn't easy. The technology needed to detect gravitational waves didn't exist, and the project would require years of work, countless trials, and an incredible amount of resources. It wasn't just about creating a new scientific instrument, it was about building something that could fundamentally change the way we understand the universe. But Rainer was determined. His vision was clear, and he was willing to do whatever it took to make it a reality. The road to success was long, and there were many setbacks along the way. But Rainer and his team pressed on, undeterred by the obstacles in their path. Their efforts paid off in 2015, when LIGO made history by detecting gravitational waves for the first time. The discovery was a breakthrough that confirmed Einstein's theory of general relativity and opened up an entirely new way of observing the universe. It was a momentous achievement, one that earned Rainer Weiss and his colleagues the Nobel Prize in Physics in 2017. The discovery of gravitational waves marked the birth of a new field of astronomy: gravitational wave astronomy. For the first time, scientists could hear the universe not through light or radio waves, but through the very fabric of spacetime itself. This discovery has already led to groundbreaking new insights into the nature of black holes, neutron stars, and the fundamental workings of the universe. But Rainer's story doesn't end with the Nobel Prize. The success of LIGO has opened the door to an entirely new era of scientific discovery. As more and more gravitational wave observatories are being built around the world, the field continues to grow, and our understanding of the universe expands. Rainer Weiss's contributions to science go beyond just one discovery. They have laid the groundwork for future generations of scientists to continue exploring the cosmos in ways we could never have imagined before. So, how did Rainer Weiss, a young boy who fled the horrors of war, become a Nobel laureate and change the way we understand the universe? The answer lies in his relentless pursuit of knowledge, his unyielding determination, and his ability to turn the impossible into reality. He taught us all that no matter where we come from, no matter the challenges we face, if we stay curious, stay determined, and never stop pushing forward, we can accomplish incredible things. Rainer's story is one of resilience, perseverance, and intellectual brilliance. It is a reminder that science is not just about discovering new facts, it is about pushing the boundaries of what is possible and seeing the world through a different lens. From the streets of New York to the halls of MIT and eventually to the Nobel stage, Rainer Weiss's journey is proof that even in the face of adversity, the pursuit of knowledge can lead to extraordinary discoveries. And who knows? Perhaps your own journey, no matter where it begins, will one day change the world as well. If I told you that in 1915, Albert Einstein introduced a theory so groundbreaking, so wild, that it almost sounded like a fairy tale, would you believe me? That theory was Einstein's general theory of relativity, and it predicted the existence of something called gravitational waves. Simply put, gravitational waves are ripples in spacetime itself, waves that travel across the universe, just like the ripples that spread across water when you toss a stone into a pond. But here's the mind-blowing part: no one thought they would ever be able to detect these waves. The idea was so far-fetched that many scientists dismissed it as nothing more than a beautiful, unprovable theory. Gravitational waves are incredibly faint, so faint that their effects were believed to be so small that even the most advanced technology of the time couldn't detect them. Einstein's prediction was a bold one, but would it stand the test of time? Fast forward to the late 20th century, and enter Rainer Weiss, the physicist who looked at this impossible theory and said, "Why not? Why can't we detect these waves?" At that time, no one believed it could be done. Most of the scientific community considered gravitational waves nothing more than a theoretical curiosity. But Rainer Weiss saw something different. He saw a challenge. He saw an opportunity to do what no one thought was possible. If we could hear the universe, he said, it would be through gravitational waves. And that was the spark that ignited the LIGO project. Now, let's get one thing straight: Rainer's journey wasn't going to be an easy one. Gravitational waves are so faint that ordinary detection methods simply couldn't pick them up. Imagine trying to catch a whisper in the middle of a thunderstorm. Even the most advanced technology of the time couldn't detect something so elusive. So what did Rainer do? He turned to a groundbreaking method: laser interferometry. Now, laser interferometry isn't something you casually tinker with in a high school science lab. This is cutting-edge technology that requires the most precise engineering you can imagine. It's like trying to measure the width of a hair from miles away with extreme accuracy. The idea was to use laser beams to measure tiny distortions in spacetime, distortions caused by gravitational waves. These waves would shift the path of the laser beams ever so slightly. To detect them, the equipment had to be accurate down to the tiniest fraction of a proton's diameter. And that's where Rainer's team stepped in. They weren't just physicists, they were laser engineers, pushing the limits of technology and precision. Can you picture it? These scientists, standing in labs with giant machines, sending laser beams through elaborate setups designed to measure these tiny changes. The lasers were precisely aligned, and they needed to stay in perfect sync. Even the smallest error would throw off the results. And when we talk about tiny, we mean tiny. We're talking about measuring shifts smaller than the width of a proton. It wasn't just about laser beams, it was about creating a flawless environment where nothing could interfere with the experiment: not a single vibration, not a degree of temperature fluctuation, and certainly not the smallest gust of air. The equipment wasn't the only challenge. Gravitational waves were so weak that detecting them would require a perfect, controlled environment, something that was incredibly hard to maintain. Even the faintest disturbance could mess everything up. So, Rainer and his team had to create a system that could isolate the instruments from any environmental interference. They spent years just trying to figure out how to build a quiet environment that wouldn't disrupt their measurements. It was like trying to find the silence in the middle of a bustling city. Rainer's team spent countless hours adjusting, fine-tuning, and reconfiguring their experiments. Every detail mattered. A single stone falling on the ground could shake the equipment enough to ruin the data. But Rainer didn't give up. His persistence and determination kept the team going. He believed that if they could overcome these technical obstacles, gravitational waves would no longer be a distant dream. They would be real. And that belief was about to pay off. After years of painstaking work, Rainer and his team began to make real progress. But this wasn't the end, it was just the beginning. In 1994, the LIGO project officially launched, and Rainer became one of the core figures driving it forward. LIGO, or the Laser Interferometer Gravitational Wave Observatory, wasn't just a laboratory, it was a massive, worldwide initiative aimed at detecting gravitational waves from the farthest corners of the universe. Think of it as a giant ear, straining to listen for the faintest sound, the sound of the universe itself. LIGO wasn't just about using lasers, it was about collaboration on a massive scale. The basic principle of LIGO was simple: two laser beams traveling through vast distances. As gravitational waves passed through spacetime, they would slightly alter the path of these beams. These changes would be imperceptible to the naked eye but would be detectable with the precise instruments at LIGO. However, even with the incredible technology at LIGO, it wasn't going to be a walk in the park. The challenge was immense. Rainer and his team faced massive obstacles. They had to make the equipment even more sensitive. Any small vibration, a slight change in temperature, or even an air current could mess up their readings. The goal was to make the instruments so sensitive that they could measure a shift as tiny as 1,000th the width of a proton. It was a crazy, almost impossible task, but that's exactly what Rainer had set out to do. LIGO wasn't just a technical challenge, it was a logistical one as well. The project required scientists, engineers, computer experts, and even architects all working together to make the impossible happen. LIGO was a massive, cross-disciplinary project, with teams from around the world working in unison. Each laser beam had to be precisely aligned and controlled, and the equipment had to be installed in two separate locations, one in Washington state, and another in Louisiana. These two stations would work together, cross-checking their results and ensuring the data was accurate. As the 1990s came to a close, LIGO started to show promise. The technology was slowly coming together. In 2002, LIGO officially began collecting data. But even then, many skeptics were unsure whether this project, which had been in the works for over a decade, would actually succeed. Could it really detect gravitational waves? The team had been through so many setbacks that it was hard to imagine the dream of LIGO coming true. Yet, Rainer and his team pressed on. They understood that science isn't about making things easy, it's about pushing through the impossible. And then, in 2015, came the moment they had all been waiting for. On September 14, 2015, LIGO detected its first ever gravitational wave. This wasn't just a small blip, it was a groundbreaking, earth-shattering discovery. The wave came from the collision of two black holes, 1.3 billion light-years away. Can you imagine that? The signal that LIGO detected had traveled across the universe for 1.3 billion years before reaching Earth. And when the scientists at LIGO saw the data, they knew this was it. They had done it. They had detected gravitational waves. It was like winning the lottery, but for scientists. There was disbelief, followed by pure joy. For Rainer and his team, it was the culmination of decades of work. Every sleepless night, every setback, every failure had led to this moment. The scientific community was abuzz, with physicists everywhere celebrating the breakthrough. The world had just taken its first step into a new era of scientific discovery. For Rainer, the success wasn't just a personal victory. It was a triumph for the entire scientific community. It proved that impossible things could happen. It showed that no matter how wild or far-fetched a theory might seem, if you're willing to put in the effort and challenge the status quo, you can make the impossible possible. But this wasn't just the validation of Einstein's theory. It was the birth of a new field of astronomy, gravitational wave astronomy. With this new way of detecting waves, scientists now had a tool to explore the universe in ways they had never imagined. They could listen to the universe, not just look at it. The discovery of gravitational waves opened up a new dimension of exploration, where scientists could study the cosmos in a whole new light. Einstein had predicted the existence of gravitational waves over a century ago. At the time, no one believed it. It seemed like an impossible dream. And yet, in 2015, LIGO proved Einstein right. The discovery wasn't just a win for the scientists who worked on it, it was a victory for all of humanity. It was a testament to the power of persistence, the value of believing in the impossible, and the limitless potential of human curiosity. As we look to the future, we can only imagine the discoveries that lie ahead. Gravitational waves are just the beginning. Who knows what other secrets the universe is hiding, just waiting to be uncovered. With LIGO and other advancements in technology, scientists will continue to listen to the universe's deepest, most ancient sounds. And who knows? The next groundbreaking discovery could be right around the corner. The success of LIGO was the product of decades of work, countless setbacks, and one man's unyielding belief that science could do the impossible. Rainer Weiss and his team showed us that with determination, dedication, and a willingness to think outside the box, even the most distant dreams can come true. In the end, this isn't just about detecting gravitational waves. It's about a new way of understanding the universe. It's about opening new doors for exploration and discovery, and continuing a journey that began more than a century ago with the wild ideas of one man, Albert Einstein. October 3, 2017, Rainer Weiss and his LIGO team received the ultimate recognition, the Nobel Prize in Physics. It was the culmination of a journey that had begun decades earlier, a journey full of challenges, setbacks, and moments that tested their resolve. Picture the scene. Decades of hard work, testing, adjusting, and fine-tuning. Finally, the global scientific community was saying, "You did it." But let's be real, the Nobel Prize doesn't just go to anyone. It's the Oscar of the science world, a glittering symbol of success that represents countless hours of experiments, data collection, recalibrating instruments, and, yes, sleepless nights. The road to this honor wasn't easy. In fact, the challenges Rainer and his team faced would have made most people give up. But they didn't. They stuck with it. The road was long and filled with doubt. In the early days, not many believed that gravitational waves, the ripples in spacetime predicted by Einstein, could even be detected. But Rainer believed. His unshakable faith in the project and the science pushed him and his team to do what many thought was impossible. It all started with a crazy idea. Decades ago, when people thought it was just science fiction, Rainer and his team believed they could find proof of gravitational waves. Who could have imagined that years later, that wild theory would lead them to stand on the Nobel Prize stage? It wasn't just luck, it was dedication, persistence, and an unwavering commitment to science. The discovery of gravitational waves didn't just shake the world of physics, it sent ripples through astronomy, engineering, and even international collaboration. The detection of gravitational waves wasn't just a breakthrough for physics. It sparked a new era of collaboration between scientists from different countries. This wasn't just about physics anymore, it was about building something bigger, a global network working together for a shared goal. It was an exercise in teamwork, not just in the laboratory, but across national borders, cultures, and disciplines. And that collaboration didn't just change the way science was done, it led to new tools, new technologies, and even new fields of study. Gravitational wave astronomy, for example, emerged as a whole new discipline. But it wasn't just the discovery of gravitational waves that was revolutionary. It was the technology that made it possible. LIGO and other detectors had to be crafted with pinpoint precision, something that pushed engineering to its limits. This wasn't just a win for physicists. It was a victory for engineers and technology developers. Detecting gravitational waves required incredibly precise instruments. These devices had to be so accurate that even the slightest fluctuation could ruin the entire experiment. And to make it work, engineers had to innovate. They had to build new systems, test new ideas, and create tools that had never been seen before. This achievement wasn't just for physicists in the lab, it was a victory for the entire engineering world. Looking back at 2017, Rainer Weiss and his team didn't just win the Nobel Prize for their discovery. They won it for their relentless pursuit of something that was, at the time, almost inconceivable. The Nobel wasn't just a stamp of approval for their decades of work, it was an acknowledgement of the entire field of gravitational wave research. And it wasn't just about the science, it was about the perseverance to push through years of uncertainty and challenge. The detection of gravitational waves changed the way we think about the universe. It wasn't just about proving Einstein's theory, it was about unlocking a new way to explore space. It was about seeing the cosmos in a whole new light. This discovery opened doors to new questions, new possibilities, and new ways of doing science. It wasn't just a triumph for one man or one team, it was a victory for all of humanity. And yet, the journey isn't over. Far from it. The future of gravitational wave astronomy is still being written. LIGO is already undergoing upgrades to improve its sensitivity. Other collaborations, like Virgo and Cagra, are making strides to detect even fainter signals. The global network of detectors is expanding, and the precision of measurements is increasing. New detectors are in development, and they will be even more sensitive than the ones that led to LIGO's groundbreaking discoveries. In the coming years, we may detect signals from billions of light-years away, signals that could reveal even more about the universe's hidden secrets. We could hear black holes collide or witness the birth of neutron stars. These discoveries will change our understanding of the cosmos in ways we can't even imagine right now. This progress is pushing the boundaries of what we know. We are living in an age of scientific breakthroughs, and the work that Rainer Weiss and his team began will continue to shape the future of astronomy, physics, and engineering. The success of LIGO is just the beginning, and the possibilities are endless. It's like opening a new chapter in a book that's still being written, one discovery at a time. Rainer's impact goes beyond the Nobel Prize. He's been instrumental in pushing forward not only the science of gravitational waves but also the global effort to collaborate and innovate. Every gravitational wave detection from this point forward carries his influence. His work has laid the foundation for future scientists to build on, and his contributions will continue to ripple out for generations to come. What made Rainer Weiss so successful? His leadership, his determination, and his commitment to his team. He didn't just focus on the science, he focused on the people. Rainer wasn't a lone genius, he was a leader who understood that science is a team effort. His ability to encourage collaboration and push through challenges inspired his team to keep going when the road got tough. He was patient and methodical. Every obstacle that came up, Rainer faced with calm resolve. He didn't get flustered. He didn't panic. He knew that science is a long game and that breakthroughs take time. His unshakable belief in his team and in the process kept them moving forward, no matter how many setbacks they faced. Even when things seemed impossible, Rainer didn't back down. He kept pushing, kept believing, and eventually, his persistence paid off. That's the kind of leader he was: steady, patient, and always looking for solutions. He taught his team that science isn't just about the big wins, it's about the small steps you take every day. Every breakthrough, no matter how small, gets you closer to the bigger picture. It's about refusing to give up, even when it seems like nothing is going right. And that's the spirit that drove LIGO to success. Rainer's leadership wasn't about being the smartest person in the room, it was about getting everyone else to think big and work together. He didn't need to be the hero, he just needed to help everyone else be heroes in their own right. And that's how LIGO succeeded. It wasn't just about Rainer, it was about the team. Every person played a role, and Rainer made sure they all knew it. His legacy will be felt for years to come. The discoveries made by LIGO have already revolutionized our understanding of the universe, and as new scientists step up to continue this work, they'll be standing on Rainer's shoulders. The road he paved will guide future generations as they continue to unlock the mysteries of the cosmos. So, when we look back at Rainer Weiss and his team's Nobel Prize, we don't just see a win for science, we see a win for collaboration, for perseverance, and for the idea that no challenge is too big when we work together. The legacy of LIGO isn't just the discovery of gravitational waves, it's the way it showed us what science can do when we all pull together. As we look to the future, we know one thing: Rainer Weiss has set the stage for the next great leap in science. The universe is calling, and with the tools Rainer helped create, we're ready to listen. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.